Do you know anything about the Cybertruck? You have, of course. Everyone is aware of it. However, this car is altering the game in a revolutionary way, and no one seems to be talking about it. There are absolutely amazing synergies and cost savings coming from SpaceX and Tesla's cooperation that no other manufacturer can match. Welcome to this video, where we'll explore the world of Tesla's achievements and its never-ending search for cutting-edge concepts using first principles analysis. Charles Kohlmann, a talented alloy specialist who had previously worked at Apple and SpaceX, was acquired by Tesla in 2015. Kohlmann brought a wealth of knowledge and experience to the table with his PhD in material science and engineering, and his expertise has found its way into the Cybertruck in ways that will transform the automobile industry forever. Make sure you subscribe to Tesla Stock News before we get started. That being said, let's begin this video. For the time being, let's set aside the 8,000-ton Giga press intended for the Cybertruck's rear body. Sure, it's a significant issue, but that's not what we're discussing today. We are discussing the one feature of the Cybertruck that has an indirect bearing on SpaceX's Starship, a feature that really demonstrates Tesla's revolutionary nature. Tesla's success can be attributed to its commitment to basic principles, continuous improvement, and innovative idea implementation. It's like breathing the company's own air. Charles Kohlmann, a specialist on alloys, was hired by Tesla back in 2015. He joined Tesla and SpaceX after leaving Apple. At both companies, he serves as the head of materials engineering. Kohlmann co-founded Questec, a business that created and marketed a number of novel materials, engineering tools, procedures, and alloys after receiving his PhD in material science and engineering from Northwestern University. After that, he headed Apple's product design department for 3 years before joining SpaceX and Tesla. We learned a few months ago that Steel Dynamics and Tesla had inked a supply contract for the Cybertruck. Tesla will get steel from a new electric arc furnace, EAF, steel plant being built by Steel Dynamics in Sinton, Texas. By melting steel scraps and turning them into liquid steel using high-current electric arcs, the EAF process produces almost 25% of the world's steel. Ferris 85 will install and run the biggest slitting line in North America at SDI's new factory in Sinton, Texas, according to Metal Center News. The slitter's ability to create slit widths between 8 and 85 inches is essential for building the Cybertruck's body. Just as it outsources the fabrication of its Hardware 3 and Hardware 4 fully autonomous chips, Tesla is developing its alloy, but will also need to devise new ways to manufacture it. With the new stainless steel alloy for the Cybertruck, a comparable circumstance occurs. The secret to Tesla's supremacy is concealed in plain sight at the SDI factory in Sinton, Texas, which is 3 hours distant from Giga Texas in Austin. The ultra-hard 30X cold-rolled stainless steel proprietary alloy, which Elon Musk says has the potential to shatter a stamping press, is the key to the puzzle. The distinctive planar design of the Cybertruck is due to this special alloy, which cannot be stamped like regular steel. Let's examine the specifics in more detail. In response to Viv's post, Elon Musk made an intriguing discovery. Before the new steel alloy was used in the Cybertruck, it was first used in SpaceX's Starship spacecraft. Elon disclosed that although titanium skins were initially intended for the Cybertruck, stainless steel turned out to be a far more durable choice for Tesla. But this choice is more complicated than it first appears. Elon's real goal is to raise demand and lower material costs for the alloys that SpaceX finally decides to produce in larger quantities. Higher quantities translate into cheaper costs, so both SpaceX and Tesla benefit from this clever technique. It is noteworthy that the need for alloys in space applications is not the same as it is on Earth. Space alloys need to be able to endure extremely high temperatures when they re-enter the Earth's atmosphere, but on Earth, rust inhibition is the primary concern. Notwithstanding this disparity, it wouldn't be shocking to see Tesla develop the Cybertruck in the same way that SpaceX does as it continues to investigate other materials. Elon's remarks from the previous summer demonstrate Tesla's dedication to continuously developing materials. As metal compositions and forming techniques vary quickly, Tesla will make less sense out of conventional naming conventions like 304 liters. When it comes to materials and designs, traditional automakers tend to stick with them for decades, but Tesla lives on ongoing research and development. They continuously innovate and apply improvements to the basic level of chemistry for the advantage of the typical consumer. The Cybertruck's incredible resistance to dents, scratches, and rust is only one of its amazing attributes. The problem with rust in particular is more serious than most people realize. What precisely are the cold rolling alloys 30X and 304 liters made of then? I could spend hours discussing this subject, but for now, allow me to give you the main ideas and conclusions. Some sheet metal engineers may take issue with Elon Musk's description of stainless steel as ultra-hard, as strong in terms of strength or yield strength would be a more appropriate engineering term. Although Elon is aware of this, he also recognizes that yield strength may not be a concept that the typical Tesla fan is familiar with. The idea of yield stress or yield strength denotes the critical point at which a material begins to distort plastically. When a substance is subjected to external forces that cause it to permanently alter shape, this is referred to as plastic behavior. In essence, yield strength establishes the highest load or force that may be applied without permanently deforming the material or changing its shape. Let's now explore the fascinating history of the 30X and its significance. We now have more information because of Thomas Bradford's curious mind, who asked a question and got an answer around the end of 2019. He asked Elon Musk if the alloy type was indicated by the 30X, where X stood for an ambiguous number like 303 or 304. Or he wondered if that actually meant 30 times the hardness. Elon acknowledged that was a fantastic question and answered with admiration. He disclosed that it was a novel variety of stainless steel from the 300 series, which had undergone several cold working procedures. The precise composition was not 303 or 304, depending on the kiloton pressure used at the time, but rather a novel series that repeatedly experimented with cold pressing. The austenitic family of alloys, which includes the 300 stainless steel series, is renowned for its affordability, durability, and resistance to corrosion. Elon stated that the alloy intended for use had a thickness of 3 millimeters, or roughly 0.118 inches. The steel of the Cybertruck's doors is 3 times thicker than most other door panels, as can be seen from this thickness comparison. Steel is a metal with a crystal structure that can be either body or face-centered cubic. It changes from one phase of the crystalline structure to another when heated and then cooled. When speaking about terminology like martensitic or austenitic, this distinction is essential. The alloy used in the Cybertruck is made of austenitic stainless steel, which is not magnetic. It can, however, develop mild magnetic characteristics via cold rolling or cold working. The austenitic category includes a number of stainless steel varieties that are included in the 300 series. Moreover, Elon has before tweeted about the meaning of the letter L in a concise manner. That indicates extremely low carbon in this scenario. For example, the maximum carbon content of 304 stainless steel is 0.08%, while the maximum carbon content of 304 liters stainless steel is 0.03%. Even though 304 liters has a lower carbon content than 304, it still works well for welding and in corrosive situations while being structurally weaker than 304. It is anticipated that weld joints would endure over time. Similar to battery chemistries, each type of stainless steel series has advantages, disadvantages, and trade-offs to consider. Elon's last statement mentioned the particular stainless steel series as 304 liters. It's crucial to remember that this will be a custom alloy, thus Tesla and SpaceX won't be using any of the conventional 300 series alloys. We do know that the alloy will go through cold rolling, a work hardening and finishing procedure that compresses hot-rolled steel between a number of power rollers to create thinner and tougher steel sheets, even though specifics are yet unknown. Applications requiring exceptional strength, surface quality, and precision are well suited for cold-rolled stainless steel. Cold rolling does not require layers, unlike what many people think. Its major goal is to provide consistency during the cold rolling process by keeping tight tolerances in thickness and flatness. The crystalline structure of hot rolled steel elongates and dislocates in the direction of the roll as pressure is applied to it. This effectively increases the yield strength of the material. Recall that Ferris 85 was a supplier of hot rolled steel to Tesla. After heat rolling, cold rolling produces steel that is more resistant to stress, breaking, and deformation. Let's now address a widespread misunderstanding. We don't need to brag about the alloy being 30 times harder or stress how well it can withstand 30 cycles of rolling. Though it's